16, evaluate the integral of x to the fifth plus x over x to the fourth. It would be nice if I could use just take the integral of the top and the bottom, but I can't. So what I'm going to do is bring my x to the fourth up top. So this will be the integral of x to the fifth plus x times x to the negative 4. I now get to distribute the x to the negative 4 to both parts. So I'm going to get x plus x to the negative 3. I'm adding the exponents as I do that. And now from here, I could take the integral of each part. Remember, we'll increase the power by 1 in each one of those. So this first one will be 1/2 x squared. And then the second one, if I increase my power by 1, I'll get x to the negative 2. Multiplying by the reciprocal on the outside will give me negative 1/2. So rewriting this will be 1/2 x squared minus the 1 stays up top, but the 2 is going to stay on the bottom and the x is going to move to the bottom. So that's how that part is going to look like. And then of course we have plus c. Number 17, evaluate the integral of the x times the square root of 1 minus x squared. All right, first thing that I'm going to do in this problem is rewrite this as a power instead of a square root. And then I do notice that I have parentheses, and that usually means we're going to do a u substitution. So I'm going to let u be what's inside of the parentheses, which is 1 minus x squared. Then the derivative of 1 minus x squared will be negative 2x dx, right? I notice that I have the x, I'm missing the negative 2. So I'm going to do a negative 1/2 on the outside. So if I rewrite this, I now have negative 1/2. The negative 2x it gets to be replaced by the du, and 1 minus x squared is going to now be u to the 1/2. And now I can go ahead and take the integral. This is going to be negative 1/2 times. If I increase my power by 1, I'll get u to the 3/2, and then reciprocal on the outside. If I simplify that, the 2's are going to cancel, so I'm going to get negative 1/3 u to the 3/2, and then if I replace my u, I'll get negative 1/3 1 minus x squared to the 3/2 plus c. Number 18, evaluate the integral of cosine of 3x. All right, this is a pretty straightforward problem, but the 3x is going to cause us issues, so I'm actually going to put that in parentheses, and I am going to do a u substitution. So I'm going to let u equal 3x, and then the derivative of 3x will just be 3 dx. And then I notice I'm missing a 3, so 3 goes on the inside, 1/3 goes on the outside. So if I rewrite this problem, I'll have 1/3. The 3 dx get replaced with du, and then I have now cosine of u. All right, bring my 1/3 down. The integral of cosine u is just sine u, and now I just need to put my u back in, which was 3x and plus c, and I am done. All right, number 19, find the function y equals f of x equal if f prime of x is equal to 3x squared and f of 1 is equal to 8. So I notice that I'm at the derivative and I need to just get to the original. So to get from f prime to the original, I'm actually going to take the integral of 3x squared. And if I do that, I'm going to get y is equal to, that should just give me x cubed plus c, of course. And then they did give me information to find c, so I know my y is 8, this is x, and this is y, and then 1 cubed plus c, so I'm going to get 8 equals 1 plus c, and c is equal to 7. So my final equation is going to be y equals x cubed plus 7. And there we go. All right, problem 20. Let f of x equal the integral from 1 to x of t cubed plus the square root of t dt. Find f prime of x. So this, if you recall, this is actually the second fundamental theorem of calculus. I am going from a constant to a variable, which allows me to apply the second fundamental theorem of calculus. Basically what this question is asking me to do is to take the derivative. So if I take the derivative of this side, I'd also have to take the derivative of this side, and if you recall, taking the integral and the derivative, they cancel each other out. So the only thing that I need to do is replace, I'm just left with this, but I am going to replace my t's with an x. So f prime of x will equal x cubed plus the square root of x, and I am done.